All right, so how do you guys feel so far between review worksheet 1 and 2?
I'm feeling good. I think I just need to continue practicing with it.
Okay, yeah, and we could definitely do more of these problems. How about others of you?
I feel good about it too.
Okay, any specific struggles that you have with certain problems where where you find yourself making mistakes?
Not really.
Not really. Okay. All right. So worksheet 1 and 2, you guys don't have any questions there. I'll just create new problems for us to do. Okay. All right. So give me a moment. Let me create some for us to try here. All right, so let's look at our example here. We have y equals e to negative x. We have y equals 3. We have x equals 2. So those are our equations of the boundaries that's creating our shaded region here. Okay, so find the area of the region. What do you guys want to try here? Top minus bottom or right minus left?
Go to top minus bottom.
Yeah, top minus bottom works. We could also do right minus left, but right minus left would require some readjusting. But yeah, I think top minus bottom may be the easier, faster path. Okay, so I'll go ahead and redraw that shaded region here. Top minus bottom. Oh, here it is. Okay, so top minus bottom. All right, what's the top graph and what's the bottom graph?
Would the top be y equals 3?
Mm-hmm.
And then would the bottom be e to the negative x?
Yeah. All right, so we have an area formula that's perfectly fit for that. All right, integral from x1 to x2. We know we're working with that formula there. All right, so top and bottom are ready to go, but we still need to find what?
Intervals.
Yeah, we need to find those bounds, right? Is there one that's easy to spot?
Maybe like the 2, because it's just like it's on the it's the same as the problem.
Yeah, this is easy to spot. This is a vertical line, so we know that we know that upper bound is going to be 2. But this one, we got to at least set equations equal, right? So we want to find that intersection between y equals 3 and y equals e to the negative x. All right, so we'll set them equal to each other. Either graphing or through 36 Pro, NumSolve, either way. I think maybe zoomed out a little too much here. Okay. Second trace, intersect. Pick a point on the line that's close to the curve, to the intersection. Pick a point on the curve that's close to the intersection, hit enter. 0.693. We care about the x value. Oh, negative. Well, let's go ahead and put down the y value. Yeah, well, we know it's going to be 2, right? All right, so. All right, so here's my area. Top graph minus bottom graph. 3 minus parentheses e to the negative x. Right, and I always like to have students put parentheses here. You just never know when you need it with multiple terms, so I think it's always a good habit to leave your bottom or your left expression in a set of parentheses so that we don't forget about the negative that may impact multiple terms. Oh, and then if you're doing numsolve to find that intersection, you could also do that as well. 3 equals e to the negative x. Equals 3. Negative 1.09. Let's see. Does it come back up again? Let's try negative. Negative 1.09. Are you guys getting something that is... Oh, wait a second. I put y equals 2 in my calculator. Sorry about that. X is y equals 3. X equals 2. Okay, I messed up. 3. Is this the solution you got? Is that the...
I got the negative 1.0992.
Okay, yeah, sorry about that. Yeah, I entered in the wrong function here. Let me try again.
Oh, okay.
That's why. Yeah, I had the wrong function here. Yeah, sorry if that messed with what you were hoping to get. Okay, negative 1.09. All right, enter this into our calculator here, math 9. Two is our right bound, and 3 minus e to the x negative x. All right, you guys can double check my work. Do you guys get that as well? 6.431.
I got the same thing.
Okay. All right, part B, we're going to take the shader region and we're going to be rotating it around our axis of revolution at y equals 3. What do you guys think here? Disk or washer method?
Disk.
Yeah, this method, right? Up against a flat surface of our shader region. No gaps, no need for a second radius. All we need is one big radius. Okay, so extend from our axis to our boundary of our shader region. That's my big R of X. All right, top minus bottom. This is at y equals 3. And this is at y equals e to the negative x. We're going from the left to the right value. Our bounds still going to be negative 1.098. All the way to 2, because 2 is our vertical line there. Okay, so here's our volume formula for this method. Left to the right endpoint, left endpoint, negative 1.098. Let me write the formula first. All right, we know our radius is just going to be top minus bottom, 3 minus parentheses e to the negative x. And we're just going to insert our bounds into our formula. And then big radius squared. All right, do you guys match mine?
Yeah, I got the same number.
Okay. 15.190 pi. All right, let's do part C. Rotating around x equals -2. So I'll just put this on a separate sheet and I'll redraw the graph. Anybody still need to look at A or B? All right, so we know this point is all the way over at negative 1.098. So negative 2 is going to be somewhere here, right? All right, so rotation is occurring. We have to decide between disk or washer method. What's this going to be?
This would be washer because like the little
Yeah.
gap.
Yeah, there's that gap, right? Even if it were all the way up here, it'll still be washer, right? So yeah, but here it's more obvious. Definitely going to be washer method. Horizontal radius, 2 of them. Okay, so what do we have to do next now that we have our radius drawn?
Do we have to convert the y equals z to the negative x?
Yeah,
like
that's
x
right.
equals?
Our horizontal radius requires our equations to be in the correct form, and the y equals e to the negative x is not quite ready for that. So we're going to have to work with that equation. So y equals e to the negative x, we can write that down first. All right, so what steps would you take to eventually get that x by itself?
Would you take the natural log of both sides?
Yeah, natural log allows that exponent to freely move, right? Yeah. That negative x is now free to move. We can push that down in front. Natural log of e just goes away. Divide both sides by -1, so x equals negative natural log of y. So we have an equation that is just right for that curve. X equals -2, that's involved here, and also x equals 2, right? That's the other boundary that we have. I think we have everything we need to build our radius. We have this line, we have the curve, and we also have the axis. Big R of y. Right minus left. So 2 minus a -2. Which is just 4. Okay. Right minus left, right endpoint for big little r is sitting on the negative natural log of y, minus parentheses, left endpoint is sitting at -2. +2, I just like to have positive value first, but you don't have to. It's up to you. Okay, how are we doing so far? Everything makes sense? All the steps, all the procedures, good for you guys? All right.
How are we gonna end up getting the intervals?
Yeah. Let's talk about that. So, v equals pi integral from y1 to y2 big radius squared minus little radius squared. All right, we have the perfect substitution for big R and little r. Those are good to go. But the bounds, right? The bounds we got to think about here. We're stacking these circular rings here from lowest to highest y value. Right? Is there an easy one? Is there an easy bound that's easy that we can just know right off the bat?
Y equals 3.
Yeah, we know upper bound is y equals 3. Okay, so that one we're good with. I think the question is, how can we find this y value? Any ideas?
There's a way we could do it with the zoom box intersect.
Yeah, that's the thing with zoom box intersect. I think the calculator is not able to graph a vertical line.
Yeah, I went ahead and I tried to do that part, but I got stuck there. I didn't know how to do that on the calculator.
Well, let's think about this here. Is there an easy way to find that y value looking based off of the original function?
Oh yeah, like y of 2, right?
Yeah. As I know this point, I know the x value at this point. The x value is 2, so what if I just put 2 into the function, and in return, it'll give me the location of the y value. Yeah, so maybe that's the easier way there. We know information about this ordered pair. We know the x value is 2. We just have to find out that y value. So since y is equal to e to the negative x, I'm just going to put 2 into the function. So e to the negative 2. Do you guys get 0.135?
Yes.
Yeah, so it looks like this point is still above the x-axis, right? Still in the positive region. Yeah, so that's an easy way to do it. Just go back to the original equation and just look for order pairs. All right, so we have 0.135. I think we have everything we need, right? Big radius minus little radius. All right, check my work here. Do you guys get the same thing?
Yes.
Okay. Don't forget pi units cubed. All right, let's do one of each type here. We'll do part D as well. And part D will be cross-section. Same shaded region, though. And let's do perpendicular to the y-axis. And let's build a rectangle whose height is 1/3 that of the base. All right, there's my shaded region. Which direction are we going to be drawing our base length? Do we want it to be vertical or do we want it to be horizontal?
Vertical.
Why?
This is perpendicular to the y. Oh wait, I had it switched up. No, horizontal because that's
Yeah. So spend your time with this, right? There are 4 different ways of saying this: parallel or perpendicular to the x and y axis. So take the time to just visualize everything, right? Start with the y-axis, which is vertical, and we want it perpendicular to it. So yeah, so take your time with it. Horizontal. Well, that's nice because we already gathered all the horizontal information from part C, right? So a lot of that can carry over. All right, base length. We know this. We know horizontal, everything has to be as x equals, so we know this is x equals 2. And we already converted this curve, right? All right, base length, right minus left, 2 minus parentheses, negative natural log of y. All right, careful with your negatives, right? That's why it's good to have the parentheses there. Helps you see things a little bit more clearly. All right, any questions so far? Are we good?
Yep.
All right, what's next?
Find the area. Or make the area equation.
Okay, let's create that area, rectangle. Formula says rectangle is base times height. All right, what can we say about the height?
It's 1/3. It's 1/3 2 ln y.
Yeah,
So
yeah. So the base will insert here. And the height will insert here. So really it's just 1/3 times these two, right? I can just combine them together. 1/3 parentheses, parentheses, which is 1/3 parentheses squared. Okay, any questions so far?
Nope.
Yeah, good. Volume. Cross section with orientation of right minus left. Right, we want to identify the lowest to highest y value because we're building rectangles from this end all the way to the top end. What's the lowest y value?
Oh, shoot. 0.135.
Yeah, we already gathered that from part C, right? We used that. And the highest is just that horizontal line 3. Okay. And then just insert our area into this slot here. And rest is calculator. Okay, did you guys get that as well?
Yes.
Okay. No pi, right? Just that decimal there. All right, any questions?
Nope.
Yeah, sweet. Go ahead.
Oh, I said no.
Okay. Yeah, we did just a little bit of everything. Just based off of one shape, we're able to do area. We're able to do this method. We did washer method. We flipped it. We did some top minus bottom. We did some right minus left. We had to look for some intersections. Otherwise, sometimes we have to just look at final order pairs. Yeah, so just taking a shaded region and applying everything that we've learned, or variations of things that we've learned for these two, for our unit 7. So
on the test tomorrow, is it going to be like what we did today, where we use the same shaded region for everything, or is it going to be different ones for each method?
I'm going to be mixing and matching. I think I have maybe a total of 4 different shapes, and some will be shared and others will just be standalone. But either way, it'll be like 7 subsections. But yeah, I'm not going to have as many as 4 sharing the same, but I may have 2 to 3 parts sharing the same graph. Yeah, but you get, I feel like you guys have seen all the variations. But I'll create another worksheet and put it up under a morning review for you guys to work on. Okay, any other questions?
Nope.
All right, so I'll put that morning review. I'll work on that review, put it later on tonight. I'll have the key attached or key next to it. And then if you guys can make it, I'll see you tomorrow morning, 7 o'clock for an early morning review. But if not, it'll be recorded, so you can always watch it and work along with it later.
All right. Thank you.
All right, thanks, guys.
Thank you.
Yeah, have a great
Thank
day.
you.
Thank you.
See you. Bye.